This is the first experiment on the coffee warmer to show the various things that I was saying in the previous video that I would demonstrate through testing and experimentation. So first things first, getting the room temperature water, 16 ounces of it, and testing to see what that temperature actually is. Here the Amprobe is showing about 78 degrees Fahrenheit, which it turns out the Amprobe is consistently off by 10 degrees Fahrenheit from room ambient up to just before boiling, which I tested because I noticed that it was off by 10 degrees Fahrenheit. So just note that throughout the rest of this video, showing that temperature, and know that it's off by 10 degrees Fahrenheit. Here I am pouring the 16 ounces of water into the stainless steel mug. And then here's the verification with the infrared thermometer showing that it is indeed 10 degrees Fahrenheit off. There's a lot going on the screen here, so I'll just walk through what's going on. The upper left corner has the infrared camera trained at the side of the mug. It has 3 locations that are being monitored. The one is at the base of the Cosori drink warmer. It's not exactly what the temperature is on the hot plate surface because it's kind of at the edge, but it gives us an indication of kind of where we are in how hot the whole thing is getting. And then there are 2 locations on the mug itself, one that is on the lower part of the mug and one is on the upper part of the mug. And then I also included a hot spot detection, which is just kind of hovering around the bottom of that thin film heating element, as you might expect, because it is the hottest spot right now, but that might change as the video goes on. On the right is the Amprobe, and it's showing the temperature of that sensor that is sitting inside the very top of the mug in the water. And there's a running timer going on in the lower right. We have the Cosori obviously telling us what it thinks the temperature is on that hot plate. And all the way at the left is the kilowatt showing the current power going into the drink warmer. And you may have noticed that I added electrical tape to the top and bottom of the mug, and that's because I forgot to put it on before I started the video, and the reason is that the mug is very low emissivity. And so in order to increase the emissivity to a point that is representative of what the infrared camera is picking up, which right now it's set to 0.95, you need to add something that will bring the emissivity up. And so that was just matte black electrical tape. Unfortunately, the thermal imaging camera cut out at this point, so no thermal imaging camera for a little while. But that's all right. Still got the Amprobe showing dutifully that it is off by 10 degrees Fahrenheit, pretty much exactly. And you can see that just by virtue of those 2 temperatures that it is quite a bit of a delta between what the hot plate is showing and what the actual temperature of the liquid is. But as time goes on, that might change. I am monitoring the surface of the liquid about every 5 to 10 minutes. And that's to just keep track of how close we are getting to the 130 degree Fahrenheit temperature. And it's important to note that I put the temperature sensor and am monitoring the temperature at the very top of the liquid, which is the coolest part. So as you go down from top of that liquid down to the bottom of the liquid closest to the hot plate, there was a gradient there, which you can actually see if you're looking at the infrared camera between the spot 2 and spot 3, which shows that spot 2, it just dropped out again. That's right, I forgot about that. Please hold, it will be back in a moment. There it is. Spot 2 is showing, actually everything reset at this point because the camera crashed. Spot 2 is showing 38.5 degrees Fahrenheit, and spot 3, which has, it's not like there's no water up there. There's water all the way up to the, pretty much up to the top. Spot 3 is showing spot 3 is showing 35.8. So it's about a 3 degrees Celsius gradient between the top and the bottom on the shell of the mug. So it's not exactly representative to the temperature of the water inside there, but it correlates to it. Briefly, I'm showing in the lower left corner the amount of power that's been consumed so far, which is 30 watt hours. It's not much. And back to power. Coming up on an hour here, and as you can see, from 68 degrees Fahrenheit, the temperature now is 114 at the very top of the liquid. So it has warmed up quite a bit from room temperature, which is impressive for only 24 watts going into the mug. Just crossed over an hour and we're just hit 120 degrees Fahrenheit at the very top of that mug. So, you know, if they had probes lower in the mug, you might be able to see that the average temperature across the entire mug probably is approaching 130 degrees already, but that's not what we're going for. I want that very top liquid to be at 130 degrees. And I thought about stirring it and doing other things, but all of that releases a lot of heat out. Even just lifting it up to measure it with the infrared thermometer isn't really representative of, it's slowing down the heating process for this particular device because I'm lifting up that lid and releasing quite a bit of heat. But it just means that if you were to repeat this experiment by just using the product, it probably would heat up the water from room temperature faster than what's being depicted here. So if this is like the slowest it would probably be, given all the conditions being similar. As you can see, as I've kind of foreshadowed in the beginning of the video, the hot spot is jumping to the top now of the mug periodically because there's steam coming out because it's getting quite warm inside that mug. Temperatures, if you've been keeping an eye on them, the location 2 and location 3 have crossed past 40 degrees Celsius. That's about 105 Fahrenheit. And the location 2 is actually approaching 46. Sorry, it is at 46. And that's pretty warm. 46 is, 115 Fahrenheit. but that's on the surface. So the temperature inside is much warmer into that liquid than on the surface, but it's giving a good indication that there's actually a lot of energy going into that mug and keeping the contents warm, especially as we see the water temperature climbing to now, according to the Amprobe, 129 degrees. So we're right there at 130 after about an hour, and we're coming up on an hour and 20 minutes. And I'll confirm that pretty shortly with the infrared thermometer. But it basically took about 80 minutes to go from room temperature to what I would consider hot but not burning hot. And I'll talk about that in another experiment. But here we are wrapping up. I take the final temperature check here as we've crossed past 130 degrees Fahrenheit. Again, 141 is actually 131 on the Amprobe, but the infrared thermometer corroborates that and shows that we've hit 130 degrees plus in the mug. There it is, 131.1.